Everyone, in this video we're going to find average rate of change of a function f of x. And the equation for the average rate of change of a function is the same as the slope of a straight line. The y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to make up an example. Let's say at 5 a.m. the temperature was 60 degrees Fahrenheit. And then at 11 a.m. the temperature was 84 degrees Fahrenheit. And we're going to find the average rate of change of temperature between these two times. Where on our x-axis we have time in hours. On the y-axis we have temperature. Now, I do want to point out that the temperature did not have to increase in a straight line. You know, I just mentioned slope. That temperature could have been going like this as the day went on from 5 a.m. to 11 a.m. curving and stuff. But what we're going to do to get the average rate of change of the temperature between these two times, we will take the straight line slope. We'll take the slope of the straight line between these 2 points, and that will give us our result. Well, we don't have to sketch this. Let's find the average rate of temperature between these 2 points. Okay? Do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. x1, y1. X sub 2, y sub 2. 84 minus 60 over 11 minus 5. And we get 24 degrees Fahrenheit per 6 hours. We can simplify that, correct? That's 4 degrees Fahrenheit per 1 hour. 4 degrees Fahrenheit per hour. On average, that's how much the temperature changed between these 2 points. Let's do another thing. I'm going to give you the equation of a function. Alright, f of x equals x squared plus 4x. Let's find the average rate of change of this function between the point x sub 1 equal to 2 and x sub 2 equal to 5. No problem. Use the equation of the slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, I see the 5 and the 2. I'm just going to plug them here. Here, you're 5. You're 2. Now we're stuck. Where's y sub 2 and y sub 1? It's not given. Well, we have to find them. We have to find the y sub 1. And to use that, we use this equation right here. See, this is y. f of x is y. So to find y sub 1, we need to substitute this 2 into this equation. So I'll just put a comma here. What is y sub 1? That would be 2 squared plus 4 times 2, which is 4 plus 8, giving us 12. Yeah, we just found that xy coordinate. Substitute the 2 in there. You'll find y. The corresponding y value for that x value. So at 2, it's 12. Well, what's going on at 5? Let's find that. Here, I'll put a comma. Here's our coordinate. That's x. We need y sub 2. Substitute a 5 in here. 5 squared plus 4 times 5, which is 25 plus 20, which is 45. X sub 1, y sub 1. X sub 2, y sub 2. Now we have these. Put the 45 here. Put the 12 here. We get 45 minus 12, 33 over 3, which is 11. No units were given, so we'll just leave our answer as 11. The average rate of change of this function from x sub 1 equal to 2 to x sub 2 equal to 5 is 11. On average, it increased 11 for every one x value went to the right. That's it.